Hello everyone, uh, I'm Rudy Fernandez from Universitas Andalas. I would like to present my research article with a title A Circular Patch Microstrip Antenna with a Partial Ground Plane for WiMAX and Wireless LAN application. As an introduction, WiMAX or Worldwide Interoperability for Microwave Access is a broadband wireless technology that has high access speed with a wide range according to IEEE 802.16. While wireless local area network, also called WLAN, is a network that uses radio waves as its data transmission medium. This wireless LAN using IEEE standard 802.11. This application at wireless LAN and WiMAX frequencies requires an antenna as its transmission medium. A microstrip antenna is one of antenna types that can be used for wireless LAN and WiMAX application, but has a drawback, which is narrow band. The bandwidth for covering WiMAX and wireless LAN frequency is 3.05 gigahertz. This is quite a wide band. Yeah. In this study, proposes a design antenna that has a wide bandwidth by applying a partial ground plane. Therefore, the antenna can operate on WiMAX and wireless LAN frequencies. As a methodology in this research, we started a design of the antenna, uh, the the conventional one. I mean the circular pitch antenna. This circular has a radius which is A, and this patch has a thickness which is D, and the substrate has a thickness which is H, and the, the lowest layer is a ground plane. Uh, the, sub, the substrate used for the antenna is FR4 with a thickness of 1.6 millimeter, and dielectric constant is 4.4. Based on the WiMAX frequencies and wireless LAN frequency, we can determine the resonance frequency for both bands, which is 3.825 gigahertz. We need this value to calculate the radius. As you can see in this formula, A is the radius. We know already the thickness of the substrate and the electric constant, and we need to figure it out the F, which is a logarithmic function of radiating element. This F can get from this formula based on the value of resonance frequency and also the dielectric constant. From this normal design, we apply or we modify this patch by using a line feed as a feeding for this patch. As you can see here, the feeding line is 21.35 millimeters with the width of this line feed is 3 millimeters. We have 18.24 as a radius for the patch from the equation. So in total, the dimension of this structure is 40.48 millimeters multiplied by 59.73 millimeters. Here on the ground plane, we have the same dimension as in the patch. In this normal ground plane, we have a full of copper in this layer. But since we are going to apply the partial ground plane, so the copper part in this ground plane is etched. So this part is reduced until giving a better impact on the bandwidth of the antenna. The area with the copper part is becoming decreased, yeah, as small as 19.35 multiplied by 40.48 millimeters. It's becoming partial. The proposed antenna is simulated by using an EM electromagnetic simulator. Why we need to simulate it? Because we need to evaluate the performance of the proposed antenna. The performance of a microstrip antenna is based on the value of return loss and voltage standing wave ratio. The antenna has a good performance when the RL or return loss, the value of return loss less than minus 10 dB, and the value of VSWR less equal to 2 at the expected working frequency. And the radiation pattern is set a directional one. So the simulation results show that the return loss of the proposed antenna has a minimum frequency here to the maximum frequency, the right, the most right. This two vertical line is the targeted bandwidth for the WiMAX and wireless LAN. So we can easily know that the bandwidth, the achieved bandwidth is wider than the target bandwidth. This achievement is confirmed by the value of PSWR, which is below than 2. Here, this is the baseline below than 2. This is from the minimum frequency to the maximum frequency achieved by the proposed antenna. And for the antenna also required to have a better gain, which indicate how strong a signal an antenna can send or receive in specified direction. So the maximum gain is 1.32 dB with a directional radiation pattern, just like you can see here. For the comparison between antenna parameter for antenna with PGP, partial ground plan, and without PGP is presented in this table. Antenna with PGP has a smaller value than without PGP, and the gain in antenna with PGP is better than without PGP. And also, and of course, the bandwidth of antenna with PGP is wider than the without PGP. As a conclusion, the partial ground plan on circular microstrip antenna that works uh, on WiMAX and wireless high frequency has managed to increase bandwidth by 3.14 GHz from its original bandwidth. The result of the simulation show the following parameters. Return loss is minus 17.01 dB and minus 10.55 dB at frequency of 2.3 GHz and 5.12 GHz respectively. And the maximum gain antenna is 1.32 dB. Then the antenna has a directional radiation pattern. Okay, that's the end of my presentation. Thank you very much for your uh, attention.